We added a new feature to Wisdom Wednesday called Afterthought. After we record and before we produce the program, I'm going to add some of my thoughts to the end of the program. Our show today is focusing on healthcare moonshots. Our guest speaker is Dr. Timothy Chou. Tim is a serial entrepreneur. Also joining us today is Harry Scott. Harry is also a serial entrepreneur with investments in healthcare moonshots. So Tim, tell us about healthcare moonshots.
So let me tell you the story of our moonshot mission. It does start at Stanford. As you know, I was running Oracle's cloud computing business from its very early days. I was actually the first president of that business. And when I left Oracle, I actually returned back to Stanford and started the first class on cloud computing, actually in the world, like now, 15 years ago. Well, 5 or 6 years ago, I have a student show up who's a very unique character. He has an MD, an MPH, an MBA, and he's chief of pediatric cardiology at Children's Hospital in Orange County. So I'm looking at him going, what can I tell you about anything I don't know anything about what you know about. And he said, well, actually, I believe that AI, big data, and cloud computing need to meet medicine. And so Dr. Anthony Chang, who has recently released a book on intelligence-based medicine, an avid promoter of AI in medicine, is kind of the spiritual leader of what we've been working on, and a portal into the world of healthcare, and in specific, the world of pediatric healthcare. So one of the things I learned, or many of the things I've learned, is really because of that beginning, that introduction. And so I'll just go through that quickly for those of you who don't speak a lot of healthcare. One of the most amazing things is, even to this day, right, a little kid in LA actually went undiagnosed with brain cancer for well over a month, because it was so difficult to share an MRI scan between 2 hospitals and 1 clinic, because to this day, they are still using CD-ROMs, if you can believe that. Anthony actually was providing consulting for a kid in Myanmar. They wanted to get the echocardiogram to him, couldn't get it to him. The kid eventually died on the operating room table. And, he later on got to see the echo, and he said, oh, I could have told them what to do, right? And if you now go into the world of global health, one of my old friends is she just retired as CEO of Save the Children. And I explained to her what we were working on. She says, well, pneumonia is the #1 killer of kids in Africa, pneumonia. And this is not because there's not low-cost scanner technology. There's just nobody to read the scan. In fact, in the country of Rwanda, there is 1 pediatric cardiologist. So that brings you to, yes, the world of AI has enormous promise, because you're never going to be able to build enough medical schools, whether, in Rwanda, frankly, or rural California, to supply everybody. So couldn't we take Anthony's brains, in effect, and put them into a computer? And so, but the world of AI, for those of you who spent time in it, know, and I'm particularly talking about deep learning, know that the only way these algorithms get built is through large amounts of data. And by the way, large amounts of diverse data. So just to make a point of it, if you want to build a pneumonia diagnostic for kids in Africa, you are not going to do that with, looking at CT images of kids in California. That's not how this stuff works, right? And time again, I've been part of, the AI and medicine program at Stanford. There's work going on at Texas Children's. If you go to these conferences, you hear the same thing. There's not enough data, there's not enough data, there's not enough data. So you look at it and go, well, but there is data. Now, it is not in the EMR, EHR, which, as I like to say, is just a giant billing system. It's in the CT scanner, the blood analyzer, the gene sequencer, the ultrasound. That's where the data is. But today, because those machines are not connected and have no ability to share, it just goes on the floor. It's digital exhaust. The Echo Lab at Stanford, just so one part of Stanford Children's generates 50 gig per day, but it's going into the air. So that's the challenge. How do we do this? And so a year and a half ago, a group of us who are all technologists, infrastructure people, we said, look, I think we can crack this problem. And we set ourselves a goal, what we call a moonshot, which is we want to connect all 1 million healthcare machines in all 500 children's hospitals in the world and enable data to be shared in a precise and safe way that will enable a whole new generation of applications to come into existence. So that's been the mission. It's a little crazy, but we thought, well, why not go big, right? So let me get to the second part and talk about, well, how the hell are we going to do this, right? So we have developed a technology, a cloud service we call an edge cloud. So why do I call it an edge cloud? Well, here's the abstraction of, and I'll just pick on AWS. Amazon buys 1 million servers. They manage the performance, availability, and security of those servers. They deliver them in an OpEx model, and they put them in about 10 data centers in the world. What are we doing? We're getting 1 million servers. We're going to manage the performance, availability, and security of those servers. We're going to deliver them in an OpEx model. The only thing different is we're going to put it in 500 data centers, meaning at the edge, in the building, at Lucille Packard or Nemours or Alder Hey or any of these different places. And if you think about it, this is no different. I mean, Harry and Jim, we're all old people. You guys remember client server computing? It's the same thing. It's just, I'm saying that, yes, the server is managed at AWS. We're managing, in effect, the client side or computing at the edge. Why do you need an edge cloud? Well, you need an edge cloud because, number one, if you've got a lot of communication, just look at, if I'm going to take 50 gig of data and put it into Azure and retrieve it, you're going to spend a lot of money. Everybody knows this, right? So large data, large communication cost. And the other one is, which obviously in healthcare, but this is true in many other industries, are very concerned about, is how do I manage security and how do I manage privacy? So we have developed this technology we call an edge cloud. We've got compute and storage cloud services, networking services. We have architected this entire thing around a wireless first strategy. So our backplane is not, wires. It's high performance networks, which are right now going to be Wi-Fi. But we've actually run a test at Stanford to, in essence, build a private 5G network around the building and use the 5G for something more interesting than downloading a movie 5 times faster. Okay, on this edge cloud, we have developed what we call digital twin applications. Digital twins, in essence, replicate the data in the machine. And by the data, I mean everything. The static data, what is the serial number of the machine? Environmental data, where is it located? What's the temperature? Dynamic data, what's the error logs that it just spit out? And then finally, what's the gnomic data? Oh, the blood analysis, the echocardiogram, the MRI, the glucose level, et cetera.
We are taking a break from our show to talk about gaining wisdom from our success ladder benchmark. Every software project has risk. This is a bet, just as much as buying a lottery ticket or going to casino. However, do you know your odds? Do you know how to improve your odds? Our success ladder benchmark gives you your odds of success by profiling your project against 50,000 cases in our chaos database. It also gives you hints on where you can improve your odds. There are only few inputs and 6 runs in the benchmark. After each run, The benchmark will indicate your chances of success. The Success Ladder benchmark is part of our membership. You can benchmark as many projects as you want and even play what-if games. You can change this or change that, and each run will tell you your chances of success. To get your Success Ladder benchmark, go to standishgroup.com. Now back to our show.
The digital twin applications then present data to what we refer to as edge data services. Edge data services, in effect, standardize the data no matter where you are in the world. So once you have a Philips ultrasound connected, I don't care if it's in Rwanda or Reading, right? The data presented to the edge is identical, right? Which then, with permissions, and that's one of the innovations we've developed, very precise. So we could share data at a single machine level to a single application. So you can extremely fine-grain how you want to share the data with edge cloud applications. And those applications are developed with what we call BevelCloud Studio. We just introduced this about 30 days ago. We held our first user conference. We called it Invent 21 for the fun of it. And we featured 6 different applications. I could go through them, but one of them is, thanks Harry, an introduction to a company he's invested in called Dyad Medical. And Dyad Medical is one of the 6 applications featured. We see the application space going everything from simple collaboration. We're working with a company which has built something which looks a lot like Instagram. So we could all look at the same image or the same data and go, well, what do you think, Jim? What do you think, Harry, right? All the way to, and we could go deeper into this, we think the best platform for what is referred to as federated learning, which is the whole idea of can I develop AI models at the edge without ever having the PII, the images, anything leave the 3rd floor of the building. This enables not only privacy, right, protection, but also network preservation, meaning I now don't need to send all the data up to some cloud in Holland. If I'm thinking right now about, oh, I'm going to build a pneumonia diagnostic in Africa, am I going to take all that data out of Africa and put it in the Amazon data center? Makes no sense, right? And then the last one, which I think is people are just at the beginning of thinking about this, which is continuous learning. The way we do learning today, the way AI works today is people aggregate enormous amounts of data into some big, giant, honking database, and then they run these, training algorithms for like 3 weeks that come out with the answer, and then they put the inference engine right into operation. But if you think about it, none of us learn that way. We don't learn that way. We learn continuously. And in a world where there is continuous data, and by the way, this is the way Siri works. Siri works with federated learning. Google Keyboard works with federated learning. In a world where there's continuous data, why use the old batch model? Why not learn continuously? And we think this method, this service, right, is game changing in how it could change how AI gets developed in medicine, frankly, whether it's in pediatric medicine or adult medicine. So that's kind of a little bit of what's motivated us, what the Moonshot is, what the technology is all about, kind of where we are today and what we see in the future. So glad to answer any questions, Jim, Harry.
Harry, you wanted to comment on Dyad and one of the things you've learned from working with Tim on this.
Yeah, it's actually been kind of an amazing process. So Dyad Medical does cardiac image AI deep learning. So right in the wheelhouse of what BevelCloud's doing. And but they focused prior to this on adult cardiac medicine because even the best hospitals, even the best urban hospitals really don't have enough pediatric cardiac data to really teach these engines enough. But the collaboration of 500 hospitals, you now have enough data to really teach these engines. Now the collaboration of the doctors and the AI engines, they learn together. And now it doesn't matter where the patient is, whether they're in an urban hospital or somewhere rural in the US or around the world, they can get the best treatment and the best knowledge because of this collaboration. And that's, a lot of people talk about democratizing data, that people throw around buzzwords all the time. In our experience, this is the first time that it's actually happening in a very cool way because it's helping kids. So we're pretty psyched about the whole thing. We're honored to be, one of the first applications on there. Dyad Medical is in their Libby applications. But this collaboration is, in my opinion, unprecedented, and it's really cool. So it took Dyad, I think Tim would know better, but I think less than 10 days to integrate into the platform, into the marketplace. So they thought it was, almost a no-op. They were like, okay, cool. Let's get data. One of the big benefits they see, though, is for the hospital IT systems, and Tim maybe can talk about this, is that each hospital, all of the 500 hospitals, would normally have to integrate with somebody like a Dyad or all the other applications. Now they don't really have to do that because it's in the edge. And that's a huge savings for the hospital. They can just start getting the benefits of the sharing without having to do all the integrations and all the other hard work that's frankly not really productive to treating patients. It's just IT work. Is that sort of where you see, Tim?
Yeah, and also I think the other side of it, which I think is the Dyad Medical point of view, is every time they go into a hospital, they have to go through all the same infrastructure questions, right?
Exactly.
How do you handle security? How do you handle privacy? What's the network structure like? Blah, blah, blah. Once we've deployed what we refer to as a zone into the hospital, it's done, right? Because we've gone through network engineering, privacy, et cetera, right, for the entire base platform, which I think speeds the ability and lets Dyad Medical, to another way to look at it, spend its time where it's most valuable, which is what the hell do you do with this data?
Absolutely. Not the first comment, but one of the feedback I got after they got it running, he's like, can we talk these guys into being on every hospital? They're big believers, and it's just working. It's seamless from their perspective. So well done.
I think let me just say, what BevelCloud is building is an infrastructure to allow thousands of applications, of which Dyad Medical is an example of what could be done with it. So BevelCloud is not trying to build applications. We are infrastructure to allow people to build applications.
Some afterthoughts. 25 years ago, I wrote a paper on the research done by the Seattle Children's Hospital on what they were doing with AI and how they were looking at it to do better diagnostics. And that gave me a vision with AI on the medical systems. So over the last 25 years, AI medical technology has had some fits and starts. And there have been some failures, but it never really succeeded till now. But now Tim and Harry are making the vision come true. One of our investments in our predictions of last year, we said that the new thing will be heroes. And heroes are health and intelligent research organizations like Harry's and like Tim's. We look forward to the breakthroughs from these heroes, and it might include discoveries on curing cancer and other types of treatments, as well as heart and brain diseases. So we see the future, and the future is bright for these heroes and Tim and Harry and people like them that are leading the way for a better health system. I want to thank our guest and our panelists for being part of the show. And thank you for being part of the show. I hope we have given you a few minutes of wisdom. We look forward to seeing you next time on Wisdom Wednesday. This is your host, Jim Johnson.